Solutions to the 2026 BECE Maths Paper 1. Question 11. Find the image of the point 2 minus 3 under the transformation xy goes to x y minus 2. This means that if we have x, whatever the value of x is, the new value remains x. And then whatever the value of y is, it becomes y minus 2. So in the case where our x is 2 and our y is minus 3, let me write this. Our x is 2 and our y is minus 3. If we have our x to be 2 and our y to be minus 3, what is the new x going to be and what is the new y going to be? This mapping says that x remains the same. That means that the new x is 2. And then the new y should become the old y minus 2. So y becomes minus 3 minus 2. That means that y is minus 5. So our new coordinate is going to have x being 2 and y being minus 5. And that is C. The next question is question 12. A square of area 144 centimeters squared has the same perimeter as an equilateral triangle. Find the length of a side of the triangle. So we have a square. You can sketch that. We are told that the area of the square is 144 cm squared. So what do we know about the areas of squares? If you have a square with this side being L, this side is also, the length of that side is also L. And the area of the square is equal to L squared, or L times L. So if we have 144 cm squared being equal to L squared, then what is L? L is just going to be the square root of this number. So L is the square root of 144 cm squared. I'm just going to leave that out. When you take the square root of 144, you get 12. So L is equal to 12 centimeters. Now, if L is 12 centimeters, then what is the perimeter of the square? The perimeter is just the distance around the whole figure. So we have 4 sides. 1, 2, 3, 4. So the perimeter is just 4L. Perimeter is just 4 times L. And we've already found L to be 12. So 4 times 12 centimeters, and that gives us 48. That's the perimeter of the square. Now, if this square, which has a perimeter of 48 cm squared, has the same perimeter as an equilateral triangle, then we are being asked to find the length of a side of the triangle. Now, an equilateral triangle is a triangle which has all of its sides having the same length. So just as in the square, all the sides have the same length, in an equilateral triangle, the sides have the same length. So let's call the side length K. If the length of the side is K, then the length of that side is also K, and the length of that side is also K. So the perimeter of the equilateral triangle is just going to be K plus K plus K. K plus K plus K, which is equal to 3K. So if this perimeter of 3K is equal to this perimeter of the square, which is 48 cm, then what is K? So we just set 3K equal to 48, and K is equal to 48 over 3, which is 16. So it means that the length of a side of the triangle is 16 centimeters. The next question is question 13. We're being asked to solve an inequality. 7 minus 2x is greater than 15 minus 4x. We can group like terms, so we can think of bringing this 4x here. That's the same as adding 4x to both sides. And then we can also think of taking the 7 to the other side. That's the same as subtracting 7 from both sides. So doing that, we get 4x minus 2x is greater than 15 minus 7. 4x minus 2x is 2x. 15 minus 7 is 8. So we divide both sides by 2. When you do that, you get x greater than 4. So our answer is D. The next question is question 14. Entry has 20 mangoes and 20% are rotten. How many of them are not rotten? So he has 20 mangoes and 20% are rotten. So how many are rotten? 20% of 20 mangoes. How many mangoes is that? Well, it's just going to be 20 over 100. That's the same as 20% times 20. And what does that give us? Well, we can cancel. 20 goes here 1. It goes here 5. And then 5 goes here 1. Goes here 4. So we have 4 mangoes. 20% of 20 mangoes is 4 mangoes. So that means that 4 mangoes are rotten. So if 4 are rotten, how many are not rotten? We subtract the 4 from the 20. This 4, we subtract it from the 20 to get 20 minus 4, which is equal to 16. All right. The next question is question 15. A class of 42 learners shared some oranges and each received 11. If 22 learners share the same number of oranges equally, how many will each get? So 42 learners or 42 people, 42 learners, they shared some oranges and each received 11. So one question we can ask at this stage is, what's the total number of oranges they shared? 42 learners shared some oranges. Everybody got 11. So the total number of oranges they shared was 42 times 11. This is the total. And we are now being asked, if 22 learners share the same number of oranges equally, how many will each get? So this total number of oranges, if now 22 people share it, how many will each get? And the answer is we have to divide this total by 22. So 42 times 11 over 22. What does that give us? Let me just write that again. 42 times 11 divided by 22. Well, 11 divides itself. 11 divides 22 twice. 2 divides that 1, 2, 21. So we get 21. That means that if 22 learners share the same number of oranges, everybody is going to get 21. This is one way of doing it. Another way of thinking of it, maybe I should let you comment how, if you have another way of doing it, but I see another way of doing it that I'd like you to tell me about. All right, the next question is question 16. Make y the subject of the relation p equals r minus 4y over 3. We're trying to make y the subject, so we can write this again. P equals r minus 4y over 3. Okay, so y is hiding here, and we want y to stand alone. So what do? Well, we can multiply both sides by 3 to start with. If we do that, we get 3p equals r minus 4y. Then, to let y stand alone, we can subtract r from both sides. If we do that, we get 3p minus r equals minus 4y. Then, again, to make y stand alone, we can divide both sides by negative 4. If we divide this by negative 4, divide that by negative 4, what do we get? On the right side, we're going to get y. On the left side, we're going to get this quantity, which we'll try to write in another way. So let's just write 3p minus r over minus 4 is now equal to y. So we've already found y. But looking at the answer options given, all of them are written with what the 1/4 outside and then an expression inside. So let's also try to write this one like this. The first thing we should note is that if we have something 3p minus r over minus 4, we can multiply both the numerator and the denominator by negative 1. And that will not change the fraction. In other words, 3p minus r over minus 4, if we multiply the numerator by negative 1 and the denominator by negative 1, we're going to get an expression. The top is going to become r minus 3p. So negative 1 times 3p becomes negative 3p, and negative 1 times negative r becomes positive r. And then for the denominator, we have minus 4 times minus 1. When you take that product, it's just 4. Now, this quantity is the same as 1 over 4 into r minus 3p. That means that our y is equal to this quantity. And looking at the answer options, B is the one that fits that. Our next question is question 17. A number is chosen at random from the set P equals 1, 2, 3, 4, 5 up to 10. What's the probability that the number is greater than 3? So we can use a definition of probability. One definition of probability, when you have equally likely events or equally likely outcomes, is that the probability of an event is the number of favorable, so I use the symbol to represent the number of favorable outcomes over the total number of outcomes. Total, so the number, let me just say, number of outcomes. So number of outcomes here means the total number of outcomes. That means that when we select a number at random from this set, the possible outcomes or the possible values, the ones we are calling the outcomes, are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. this is the set of possible outcomes, 10 possibilities. That means that the total number of outcomes is 10. Let me write that. So the total number of possible outcomes is 10. Now we have to find the number of favorable outcomes. Favorable means that the ones that agree with what we are looking for. In our case, we want numbers that are greater than 3. So out of all these 10 possible outcomes, how many are greater than 3? And the answer is these are the ones that are greater than 3. 1, 2, and 3 are all not greater than 3, but 4 all the way to 10 are greater than 3. So how many favorable outcomes do we have? We have 1, 2, 3, 4, 5, 6, 7. So that gives us the probability that we're looking for. The next question is question 18. Kofi paid an interest of 30 cedis on a loan he took for 4 years. If the rate was 3% per annum simple interest, find the amount borrowed. So he paid an amount of, or an interest of 30 cedis. Let me write that. Interest. The interest was 30 cedis. He took the loan for 4 years, so let's record the time. 4 years. The rate, we are told, is 3% per annum, or 3% per year. And we are supposed to find the amount he borrowed. Well, the formula for simple interest, let's start with that. Simple interest is equal to the principal. The principal is the amount he borrowed times the rate times the time. That's the formula for simple interest. So we can substitute the values we have into this formula to see what we are going to get for the amount he borrowed. The amount he borrowed is the principal. All right, so simple interest is 30. We're given that one here. It's equal to the principal. Let's call that P. That's what we are looking for. And then the rate is 3% per annum. I'll just write 3% because the time is also in years, 4 years. So I just write 4. So this is the equation we have to solve to find P. And I'll first write this. 30 equals P times 3% is 3 over 100 times 4. So we can start by multiplying both sides by 100. If we do that, we get 100 times 30 is equal to P times 3 times 4. All right, so at this stage, we can divide both sides by 3 times 4. So let's do that. If we divide both sides by 3 times 4, we get 100 times 30 over 3 times 4 is equal to P. So we have to cancel out to see what we get. 3 divides that 1. 3 goes here 10. 4 divides that 1. 4 divides that 25. So we have 25 times 10. That gives us P equals 250. So the principal, or the amount he borrowed, was 250 cedis. The next question is question 19. A cyclist traveling at 20 kilometers per hour covered a distance of 35 minutes. So 20 km per hour took 35 minutes. What time will it take to cover the same distance traveling at 28 kilometers per hour. 28 kilometers per hour. We need to find the time that will take. Now, the idea we are going to use here is that the faster his speed, the less time he uses. So there's an inverse relationship. That's the key. There's an sorry, inverse relationship. So inverse relationship between the speed, um, the speed, the speed at which he travels and the time he uses. So when his speed is high or fast, he uses less time. And when his speed is slow, he uses more time. What that means is that if we call this number, if we call this number x, let me do this. If we call this number x, then we can write this set of, or we can write this proportion. We can say that 20, this 20 over this 28 is equal to x over 35. Now, note that we have this being on top here, 20, and this being at the bottom, 28. But when we come here, we don't put the 35 at the top. We put the 35 at the bottom, and we put the x at the top. That's because of the inverse relationship. If there were a direct relationship between the two quantities, we would have done that. But because of the inverse relationship, if you do 20 over 28, you have to do the reverse on the other side. So we are trying to find x in this equation, and when we do, that will be the amount of time he spends when traveling at that speed. So we can cross multiply. If we cross multiply, what do we get? Well, we get 20 times 35 is equal to 28 times x. That means that we can divide both sides by 28. So divide this side by 28, divide this side by 28, and what do we get? Well, this cancels, but here we can cancel, we can use 7 to cancel 28 to get 4. 7 cancels this to get 5. Then 4 cancels this one. 4 cancels to get 5. So we get 5 times 5 equals x. So 25 equals x, or x equals 25. So that is our answer, 25 minutes. And just to cross check, at 20 kilometers per hour, he used 35 minutes. At 28 kilometers per hour, he's going to use less time. So this 25 being less than 35 is a good sign that we are probably right. There are other ways to check our answer, but you can go to our website, preppyonline.org. You're going to see other ways of thinking about this problem. This is a very important problem on the BECE, and it keeps coming. So it's good to have different perspectives and different ways of thinking about it. The next question is, which of the following is not a composite number? Now, a composite number, one way to define it is a number that is not prime. So a number can be prime or not prime. And if it's not prime, we say it's composite. So now that we are looking for a number that is not composite, we are actually looking for a prime number. So which of the following numbers is prime? That's the question. And Well, we can go through the options one after the other. 24. Is 24 prime? The answer is no. Why is 24 not prime? Well, a prime number is a number which has only itself and 1 as its factors, but 24 is an even number, so 2 is a factor. So let me just write that 2 is a factor. Because 2 is a factor, 24 is not prime. 4 is another factor. That's another reason 24 cannot be prime. 41. Is 41 prime? Good question. Well, 41 is prime because the only factors are 1 and 41. Its factors are 1 and 41. But I want us to go through the other numbers. 39. Is 39 prime? 39 is not prime. Why? Because it has factors. One of its factors is 3. 3 is a factor. And if 3 is a factor, so is 13. 13 is also a factor. So 39 cannot be prime. What about 65? 65 is not prime. Why? Because 5 is a factor. 5 is a factor of 65. If 5 is a factor, 13 is also a factor. I say that if 5 is a factor, 13 also must be, because a number being a factor means that we can divide by that number. And if you divide 65 by 5, you get 13. So once you know that 5 is a factor, you have to look for the number that we multiply by 5 to get 65, and that's 13. So the only prime number in the whole list is 41. Every other thing is composite. So our answer is 41. That brings us to the end of this section of going through the questions in the 2026 BECE Maths Paper 1. You can find all the questions and all the solutions in a free PDF download on our website, preppyonline.org.